Good evening, good morning, good afternoon, everyone. My name is Romeo, and we're coming live to you from the top of the Swiss Alps. I am here with Martina and Silvan, and we're going to be talking about why are we here? What was so special about today? What was so special about what we did? And why does it matter? So earlier today, we were higher up than where we are right now, and we did some flight testing. We flew the Arterian Power Quantum Systems Vector Vertical Takeoff and Landing Platform. And why did we do all of that? But first, I want to introduce these two colleagues of mine. And Martina, why don't you give our viewers a little bit of an introduction? What do you do, and what brought you up here?
I am Martina. I'm the squad lead for the Vector Scorpio integration in Auterion. My day-to-day is mostly working on the integration of hardware in our software stack. So things like radios or custom driver for components that talk directly to the flight control. I also do a lot of testing to make sure that the overall UX and UI is good and we're delivering a good product to our customers.
Thank you. Silvan?
Sure. I'm a flight control engineer. That's a very broad topic, especially for Ethereum. I'm developing flight control software, new algorithms to improve the flight behavior, make it safer, make it more efficient. But then also now specifically for this project, I'm like the main access point for Martina and for the team for flight improvements, flight tuning, and then flight testing. So a lot of fun testing activities as well.
And my name is Romeo Durscher. I'm the Vice President of Public Safety. You know, being up here in the mountains next to a glacier really reminds me of 2016, summer of 2016, when we went on top of the Adamello Glacier in northern Italy. And the concept there was we want to validate, we want to test drones in search and rescue. And it was really the concept of let's do rigorous testing and validation and see what works, what doesn't work, what can we improve so that this becomes a tool that really can help in the future during these high altitude mountain search and rescue operations. And so today I kind of had a flashback of all of this. We're in this beautiful area. We're at over 10,000 feet, which is over 3,000 meters above sea level. And we are now not just flying a multi-rotor, but we're flying a VTOL, a vertical takeoff and landing platform. And why is that special to you? What excites you about this technology? It's so different than a multi-rotor.
Yeah, it is, especially because we are able to fly for much longer time, higher altitude, and give that situational awareness. And it's really important for search and rescue scenarios and ISR scenarios. I guess the really big plus is that on Vector you can fly up to 2 hours, and that's the differentiating thing. You have eyes in the sky for a much longer period of time than any other platform at Ethereum.
And you, Silvan, the two of us, we have flown several times together. I always see this, big smile and excitement level in you, but also your calmness that comes to the table. Is this a platform you connect to?
Absolutely. Now, after over a year working with it, I built up some trust, and I know how it behaves. I know if it doesn't behave well, what to tweak, what to tune a bit, improve it. And obviously, VTOL is just very exciting to watch in general. Like having this big machine hovering in air in front of you, looking like an airplane, but without any forward motion. That still gets me after all these years working with it. And this smooth transition from hovering to fixed wing flight, and then it just goes quiet, and it's just working up there without using too much energy. And, it's cool to watch.
It really is. It's gotten to be my favorite platform to watch, especially the landing. The landing to me, when it comes back and it does its turns and lowers its altitude and then just comes in and transitions, and the sound of it, it's really beautiful. You mentioned tweaking, and that's a reason why we're up here today, right? We're in this high altitude environment. What does that mean to you?
Sure. Number one reason is the higher you go, the thinner the air gets. Thinner the air, the less mass the propeller can work with, the less mass the wings can use to keep in the air in the end. So you need to adapt the system on the air density. So we actually take this into account. We measure the air pressure, measure the air temperature, and with that, these numbers we can calculate the density of the air, and take that into the controller in the end to scale the thrust dependingly. So we need a little bit more thrust, the thinner the air gets. And the other thing is, of course, it's a VTOL, so it also hovers, and the propellers are made for efficient hover, but still they have some limits. And the higher you go, the less the thrust margin you have in the end. Like the closer you get to the limit, the less fast you can climb with the propellers. And to find out these numbers was the most interesting thing for me now.
Is it safe to say that what we're doing here, what we're learning, is improving the overall behavior of the aircraft in the future?
Yeah, it's just testing it in all kind of environments where in the end customers will use it. Really gain confidence in all kind of conditions, in hot weather, in hot weather down at sea level. Now here it's not that hot, but at least it's super high up. Yeah, all that together gives them confidence, and in the end improves the safety, of course, of the system. Yeah.
I think that's really important because we as engineers, we like to go out in the really nice days when it's easy for us, but in the end our customer needs to operate like 24/7. And so we need to really take into account in our testing and make sure that he really like the platform is up there and can perform in all conditions.
And that's a very good point. That's not only applicable to mountain search and rescue, where time matters. We have usually difficult conditions when this person is missing. It's not a beautiful day where there is no wind. It's usually quite different, cold, windy, and these platforms need to perform. But we're also seeing that in other applications. For example, just a few weeks ago, we got a request for a VTOL to fly at very high altitude and to do animal tracking, so conservation. Oftentimes, those type of projects, they also happen in high altitudes. So we're seeing more and more use cases, including inspection, where infrastructure that's high on top of a mountain, from power lines to buildings, to cable cars, need to be inspected. And these platforms need to operate in those type of conditions. So the lessons learned here today are helping us in the future for sure. Is that right?
Yeah, sure. And also our customer, we hope so.
Yeah, I mean, I'm looking very much through the developer side, of course, but at the same time, we also always test the UX, the user experience of the whole system when we go flying. So how easy is it to just build up the vehicle, get into the air, move around the vehicle where you want to look at, then use the camera and stuff. So we always test the whole package, and like testing on a mountaintop are different than testing down the flats and lowlands. And I think the UX kind of worked up here.
Yeah,
it was very easy to set up and get into the air.
So did we already learn on day one something that's exciting? Like when we went up to the Adamello Glacier, one lesson that we learned was flight time. Because of the altitude, because of the temperature difference, we had a reduced amount of flight time available. Did we see anything like this today as well? Yeah, so on vector, the flight time is a very varying thing actually. It's depending on so many environmental values like
temperature, wind, up thermals, upwinds, how gusty the wind is, and of course the altitude as well. Now we have very limited data at the moment yet, but I think it is around where we expect it to be, slightly less efficient, because just the propeller are optimized for the higher density down, a bit lower down, and also just how the physics works, you have a bit more power needed up here in the thinner air.
Also to our viewers, if you have any questions about this topic or anything Outarian, please feel free to post your question in the comments. We have our back-end team on the other side of the camera monitoring our channels, and they will give us any kind of questions that come in. So don't hesitate to ask us some questions while we're live on the air. Martina, tomorrow we're going to continue our testing and we're going to integrate ATAC and we're going to look at ATAC. What is ATAC and what do you think we can learn tomorrow that we can then utilize in the future?
Mm-hmm. ATAC is the Android Team Awareness Kit. It's like an open source application that runs on Android that allows to have like situational awareness. So we can feed to ATAC the video stream coming from the vehicle and also information about the vehicle location and where the camera is looking at. But also like you get information about where like the pilot is and where like these tablets running ATAC or phones are located. So it works really well in distributed environments where like there are different teams that might be not co-located with the pilot and needs to exchange information. And we are like really looking into validating this use case. The integration is done. We have tested several times in the lowlands, but yeah, we really need to step it up and see where it fails, where it succeeds, and what's the next step.
To me, this is really exciting because one thing that I have been trying to get us to is that having drones is a multi-layer approach. We can have multi-rotors that fly closer to the ground, closer to the incident scene, and get very valuable data to incident command. But oftentimes we also want to have a high-level situational awareness, especially on incidents or natural disasters that take hours or days, where it also matters to track movement of individuals. And so having now the capability of flying a VTOL at 120 meters or 400 feet in a big point of interest circle, seeing where all the different units are positioned, I think that's a tremendous value to incident command to get that situation awareness, to make better and faster decisions. So it's really exciting. And what we're learning here today, we will already implement in less than 2 weeks during a upcoming hazardous material validation project. And so here in 2 different environments, from high altitude in the Swiss mountains to Florida, heat, humidity, these platforms are really durable and have become usable in so many different environments. It's fascinating.
Yes, it is. And ATAC is a pretty powerful tool. It's really able to have different map layers. You can annotate the maps, share that information with all your team members. And so we can do quite some fancy things, especially for these search and rescue scenarios where you have different squads that need to communicate together, and you need that situational awareness and need to know the terrain. It's a big help, and I see the value in this integration.
And Silvan, looking at the future, we are now here in these mountainous regions. We have valleys, we have peaks. What do you think a future test could look like, or what are some of the features that in the future we may want to integrate and have available to our end users?
I would say some terrain data overall. automatic terrain following, make it easier to interact close to mountains. We have various sensors on board that could help there. We have, of course, the data from the map. I think putting this all together into a usable feature would be super nice, yeah.
So we're getting some questions in from the audience on the various different platforms, and thank you so much for engaging with us and asking some interesting questions. So today, one question was, what were the wind conditions today? We have some data on that, don't we?
Absolutely. We estimate the winds on the vehicle. It takes into account for the controller. Today was super calm, actually. Almost at zero, around 0 to 3 meters per second, which is like up to 6 knots or something. So very low. That allows us to reduce the airspeed to very closely above stall speed to be the most efficient point. Then if we would have detect more wind speed, then the system typically switch to a higher airspeed to be safe on the safe side, to have a bit more margin for turbulences and gusts. But yeah, today was super calm.
It was quite a beautiful day. It started out looking really dramatic, and then suddenly the sun came out, and it turned out to be a very, very good day to test a lot of the things that we want to do. Martina, what are the payloads that we were using today on Vector?
Yeah, it's the Tritium HD40LV. It's both electro-optical and IR. Yeah, like the visible light is as like per 10 mechanical zoom and per 10 digital zoom, and the IR as a per 10 zoom. So it's a pretty powerful payload with integrated gimbal. So it's able to do point of interest. We also have a tracking board on board, so we can track object. Pretty powerful.
That is pretty cool. We were talking about winds. One of the questions that came in was, what is the highest wind that Vector can fly in? And just a few weeks ago, I think we experienced some of those high winds. Huh?
Yeah, I mean, a couple of times now. Obviously, we run the stress test system before we ship it out. So we want to spec it with 12 meters per second, which is roughly 25 knots. Or 50 something kilometers per hour, I think, if I make the math right. And we flew with a bit more than that already. It gets borderline because the system again is optimized for airspeeds around this region. So you need to then increase the airspeed to be above the wind speed always, otherwise you will fly backwards at some point. And it also adds always some gusty environments where it's a lot of up and down, side left, and with these huge wings that are built for optimized flight performance for really long and efficient flights, you pick up a lot of these thermals or gusts or whatever. So yeah, up to 12 is the specs, and up to 15 or something we had in the past.
Just a few weeks ago, the end of March, we were flying out in the high desert in California. How is that different to what it was today?
Very windy, very hot. Beside that, not a huge difference. I mean, the interface is the same. You do the same operations. The system should perform the same. Obviously, the scene is super different. I don't know which one I like more. I think that one I like more. The snow and desert. But anyway, it was a cool experience, yeah. And you want to push it further, especially in the summer, in the heat. And we were there in March, so not yet that crazy hot. And I think we will repeat the test now till we have the high temperature summer, and it'll be a challenge for everything.
Absolutely. Martina, another question that came in is, what's the range of the radio?
It's 15 kilometers. We have CBS radio on board, the 4200 model. It's pretty cool, pretty powerful radio that has a good range. Yeah, we also did some range tests a few weeks back to actually prove out that we can fly that many kilometers away.
And today we didn't fly beyond
No.
visual line of sight. That was not the intent today.
Exactly, yeah. Just, we stick to focusing on the thin hair problem first, one problem at a time, then we will combine them to get to that scenario that our customer will challenge us with.
Yeah, so the vehicle is optionally with ADS-B, that it is detectable by other vehicles, especially by manned aircraft. But actually, the vehicles we now have with us aren't equipped yet. So it will, don't want to push too hard in the range, because you never know what's flying around here in the Alps. It's a very active area for hobby pilots or gliding pilots. So
Yeah.
yeah, be on the safe side. Flag plus man.
Absolutely. We got another question here, and that is, what was a highlight for both of you today?
Teamwork. We also have our marketing team here, and yeah, we don't get to spend much time with them, and it's nice to work with other colleagues, and yeah, just everybody chipped in, and we had pretty successful flights, so it's pretty cool day.
Yeah, the whole thing, in the end it worked without too much tweaking. And then the whole mountain experience, of course, being up here, being not so much other people around, having this place around you, with at some point beautiful weather, that was super cool.
Yeah, definitely. This day one was definitely a good day already, very informative for us. And I think, let me check if there's any other questions. Otherwise, I think we've covered a lot already in this Autarian Live session. Thank you so much, Silvan and Martina, for joining me. Thank you to Ben and Laurent behind the cameras. We are now going to bed because we have to get up in just a few hours because sunrise is awaiting us. And if the colors are just perfect, we will be capturing some of the most beautiful shots here on top of the Swiss Alps. Until then, thank you very much for tuning in. This is Romeo, Martina, Silvan from Autarian. Have a safe day, have a good day.